In previous lessons, we talked about arithmetic sequences, which have a common difference between each of the terms. Today, we're going to talk about geometric sequences, which have a common ratio between each of the terms. So let me show you what I mean. Here's an example of an arithmetic sequence, 3, 5, 7, 9. The common difference between each of these is 2. And we can find that by subtracting 5 minus 3 gives us 2, 7 minus 5 gives us 2, 9 minus 7 gives us 2. In other words, we're adding 2 each time to get to the next term in the sequence. So this is a common difference. All right, with geometric sequences, we have a common ratio. In other words, we're multiplying by the same thing each time to get to the next term. So we can find our common ratio by, instead of subtracting this minus this, we're going to divide this divided by this. So 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2. So here, where we're adding 2 each time to get to the next term in the sequence, in this geometric sequence, we're multiplying by 2 to get to the next term in the sequence. And this is called a common ratio. Whoops. And we said with our common difference, we called that D. Our common ratio, we're going to call this R. All right, let me show you how to put together an explicit formula for a geometric sequence. So the explicit formula for a geometric sequence is going to be this. The nth term, so a sub n, is equal to the first term, a sub 1, times the ratio, the common ratio, to the n minus 1 power. All right, so let's use that in our 3 examples. So our first example, we are asked to look at the following sequence. We've got 8, negative 2, 1/2, negative 1/8, etc. And we're asked to first figure out whether or not this is a geometric sequence, and then next to figure out what the common ratio is, if it is a geometric sequence. So let's look at whether or not there's a common ratio here. So negative 2 divided by 8 is negative 2 divided by 8, negative 2/8. That's the same as negative 1/4. So that's that's the ratio between this term and the following term. The ratio here is 1/2 divided by negative 2. Well, dividing by negative 2 is the same as multiplying by negative 1/2. So negative 1/2, or 1/2 times negative 1/2 is going to be negative 1/4. And then over here, negative 1/8 divided by 1/2, that's the same as multiplying by 2. So we get negative 2/8, which is equal to negative 1/4. So we do have a common ratio, so this is a geometric sequence, and the common ratio, R, is going to be negative 1/4. So there's our first example. The second example, we are asked to find the 8th term in this sequence, 5, 15, 45, 135. So to find the 8th term in this sequence, we first need to set up an explicit formula, and then we can find that term directly. So our explicit formula is going to be a sub n is equal to the first term, so 5, times the common ratio. Well, what's our common ratio? Well, 15 divided by 5 is 3, 45 divided by 15 is 3, 135 divided by 45 is 3. So our common ratio here is 3. And we're going to take that to the n minus 1 power. So there's our formula. And And now we need to figure out the 8th term. So a sub 8 is going to be equal to 5 times 3 to the 8 minus 1 power. And if we plug that into our calculator, we're going to get that that's equal to 10,935. These numbers get really big really fast with geometric sequences. All right. Next, for the third example, we're told that the 4th term in a sequence, so a sub 4, is equal to 3/8. And we're told that the 8th term in a sequence, a sub 8, is equal to 6. All right. So let's try to figure out a formula for this, and then we can figure out what the 12th term is, which is what we were asked to find in this problem. All right, so the way we're going to do this, let's set up a formula for this. So a sub n, or a sub 4 is equal to, well, it's going to be equal to the first term times the common ratio to the 4 minus 1 power, right? A sub n is equal to a sub 1 to the times r to the n minus 1. So we've just plugged in 4 for n. And so this is equal to 3/8. So a sub 4 we're told is equal to 3/8. And so that's going to be equal to a sub 1 times r to the 3rd power. And then this a sub 8, this a sub 8 is going to be equal to a sub 1 times r to the 8 minus 1 power. So a sub 8 we were told is 6, and that's going to be equal to a sub 1 times r to the 7th. Now we need to solve, we have a system of equations here, this equation and this equation, and we need to solve for a sub 1 and r. And the way that we can do that, let's solve for a sub 1. Let's get a sub 1 by itself, and then we can substitute that in down here. So let's divide both sides by r to the 3rd. We get 3 over 8 r to the 3rd is equal to a sub 1. And then we can plug in this value for a sub 1 into this term down here. So we get 6 is equal to 3 over 8 r to the 3rd times r to the 7th. So remember, r to the 3rd is just r times r times r. So there's 3 r's multiplied here, and then r to the 7th is r times r times r 7 times. And so this r to the 3rd is going to, 3 of these r's are going to cancel 3 of these r's, so that's going to be r to the 4th. So we get that 6 is equal to 3/8 r to the 4th. And then if we multiply both sides by 3/8, we're going to get that r to the 4th is equal to 6 times 8, sorry, we're going to multiply both sides by 8/3. We're dividing by 3/8. So if we multiply by 8/3 here, we're going to get, let's see, 6 divided by 3 is 2 times 8 is 16. So r to the 4th is 16. And then if we take the 4th root of both sides, we're going to get that r is equal to 2. So our common ratio is 2. And we can go back up here and plug this in. So we get 3/8 is equal to a sub 1 times 2 to the 3rd. And then to solve for a sub 1, 2 to the 3rd is 8. So we get 3/8 is equal to a sub 1 times 8. And then divide both sides by 8. We're going to get that a sub 1 is equal to 3 over 64. Almost there. Let me make some room for myself. Now that we've got our a sub 1 right here. We've got our r right here. So let me erase everything but those two pieces of information. And then we can write our formula. So a sub n is equal to the first term, which is 3 over 64, times our common ratio, which is 2, to the n minus 1. And now we're ready to find the 12th term. So the 12th term, a sub 12, is equal to 3 over 64 times 2 to the 12 minus 1, so that's the 11th power. And now we can plug that into the calculator, and we're going to get that this is equal to 96. All right, so there's those 3 examples. Hopefully that gets you started on your assignment for this week.